Good morning, everyone, and welcome to the second of our lockdown webinars. My name is Kira Proctor, and I'm the Managing Director of the A. Proctor Group Limited. I hope everyone is still keeping well, and thank you so much for the feedback from last week's webinar. We're going to keep doing these on Friday mornings until we're allowed out again, so if there's anything in particular you'd like us to cover, feel free to get in touch on Twitter, LinkedIn, or drop us an email, and we'll see what we can do to help. You can also register for our members area at www.proctorgroup.com, where we've got a range of webinars and other content, and we're going to be adding to this as time goes on. Today we're going to cover the use of aerogels in building refurbishment applications, using our Sandstone range of insulation products. As usual, we'll be following this presentation with a live Q&A session, so please type your questions into the comment box or email webinar@proctorgroup.com. We'll start with a brief overview of the basic physics of thermal insulation and how these apply to refurbishment projects, and look at how aerogels are manufactured, and then move on to the practical applications of our Sandstone range of products. We'll then move on to how they can be used to modernise the energy performance of a variety of existing structures without sacrificing utility or aesthetics. Thermal insulation basics: lambda value, R value, and U value. When we talk about insulating buildings, we usually talk about U values. A U value quantifies the rate of heat loss through a building element, such as walls, roofs, windows, and doors. The lower the U value is, the slower the heat generated by heating systems will escape from the building, and the less energy input will be needed to maintain a comfortable internal temperature. U values are affected by a law of diminishing returns, so the more insulation we add, the more we need to improve the U value further. So after a certain point, it ceases to be cost-effective or space-efficient to add more insulation. We also have to consider that not all materials insulate equally well, and to define that, we use a value called the thermal conductivity, or lambda value. The lower this value is, the less able it is to conduct heat flow, so the better it will work as insulation. Typical building materials like bricks or metal have a high thermal conductivity, while insulation materials like mineral wool or rigid foams have a far lower conductivity. If we want to account for the thickness of the material used as well, we look at a property called thermal resistance, known as the R value. This is given by the thermal conductivity of the material divided by the specified thickness. To work out a U value, we add all the R values in our wall together and take the inverse of the result. This inverse relationship is what gives us the law of diminishing returns mentioned before. So if we bring all this together, we can take the thicknesses of our materials and divide those by their thermal conductivity to get R values. We can then add those R values together and take an inverse to get the U value. The U value is then adjusted for any penetrations like structural elements called repeating thermal bridges, any fixings or air gaps present, and a few other correctional factors to give us a final U value for the element. The next step is to take all our U values for walls, doors, windows, roofs, and whatever other elements we have in our thermal envelope design, weight them by their respective area, and derive an overall average U value for the entire building. We can then adjust that to account for non-repeating thermal bridges like corner junction, floor zones, etc., and end up with our complete heat loss model. Modern new build homes typically have wall U values of around 0.2 watts per metre squared Kelvin, while traditional older properties with solid walls will be more like 2 watts per metre squared Kelvin, an order of magnitude worse, which will have a significant effect on both the heating bills of the property and the quality of life of the occupants. This is especially true where occupants are considered to be in fuel poverty or belong to a particularly vulnerable social group such as the elderly. In such groups, poor thermal insulation can lead to a variety of health problems, so it's important that upgrading such homes is considered a priority. When we're dealing with historic or listed buildings, however, this priority must be balanced against retaining architectural features and maintaining the character of the building. Significantly improving technical performance while maintaining these aesthetic quality poses a number of challenges. Ensuring that internal spaces remain large enough to be fit for purpose is of particular importance, as is minimising the effect of upgrades on moisture movement. Strategies to upgrade the energy performance of existing buildings must therefore be carefully considered, and considered holistically, as actions affecting one aspect of the building may have unforeseen consequences in another. While successive government strategies have focused on reducing energy use in older buildings, The wider implications of this have not always been fully considered. Designers must therefore have a good understanding of the materials being used in both the upgrade process and the original construction. By recognising that refurbishment cannot simply upgrade thermal insulation without also addressing the balance of moisture movement and air leakage, we can ensure the most optimal upgrade solutions are achieved. Here at the A. Proctor Group, we have invested in the importance of HAM principles, the balance of heat, air and moisture movement, and we have products and solutions taking into account all aspects of the building envelope. Types of thermal insulation. There's a great many types of insulation on the market, with a wide range of thermal conductivities. The right choice for a project depends on many factors, but today we're going to focus particularly on refurbishment applications and historic buildings, which, as we've touched on already, often pose specific challenges. The first of these challenges is that older buildings typically benefit from highly vapour permeable insulation. This is because traditional building materials such as lime-based mortar and plaster have very different hygrothermal properties from their modern equivalents. Adding insulation of low permeability, such as rigid foam, on top of such materials can lead to damaging moisture problems for two primary reasons. Firstly, adding insulation of any type will reduce the temperature of the existing wall masonry, making it more likely that condensation will occur, and will occur further to the inside as there will be less heat penetrating from the living spaces to heat up the masonry. Secondly, some insulation types such as rigid foams can prevent the dying out of condensed moisture inwards into the building, further compounding the problems. If not properly accounted for in the design, this moisture accumulation can continue unchecked, leading to increasing problems with damp and mould over time, and in extreme cases, causing the masonry to degrade due to freeze-thaw cycling. Permeable insulation prevents moisture being trapped in the construction and does not disrupt the established balance of moisture flows within the building fabric to the same degree. However, traditional types of moisture vapour permeable insulation, such as mineral fibre, tend to be very bulky. This leads on to the second challenge in historical refurbishment, preserving interior space. While mineral fibre or natural wool do a good job ensuring moisture can permeate, their relatively high thermal conductivity means achieving modern thermal standards can require up to 200 mm of thickness, which is not always practical to incorporate into an existing space. Aerogel composites such as our Spacetherm, on the other hand, can maintain permeability whilst reducing the required depth dramatically. This makes it ideal for use in rooms with limited floor area, as well as at door and window reveals and other areas, whilst retaining existing features limits the use of thick and bulky insulation. What is aerogel? Aerogel is a very low-density solid that was developed in the 1930s, but has only recently found mainstream uses. An aerogel is a gel in which the liquid is replaced by gas without shrinking via a complex process called supercritical drying. The silica aerogel used in Spacetherm insulation products is essentially puffed up sand, best described as being to sand what a Rice Krispie is to rice. The resultant structure is 97% air, entrapped in nano-sized pores, and whilst a superb thermal insulator, it is very brittle, limiting its practical applications. Spacetherm aerogel takes this aerogel and embeds it into a fibrous mat to achieve a combination of excellent thermal performance and robust flexibility. The thermal conductivity of 0.015 watts per metre Kelvin makes it among the best thermal insulants in use today, which combined with its high vapour permeability makes it ideal in refurbishments. Spacetherm aerogel is also hydrophobic, meaning it actively repels liquid water. Because the aerogel blanket contains no blowing agents, it does not release harmful gases into the building over time, nor does its performance degrade, with extensive testing showing no loss of thermal performance over a 50-year period. Variants of Spacetherm aerogel are also available with reaction to fire classifications up to A2, making these products suitable for use in almost any situation. Wraptherm. At the more extensive end of building refurbishment are facade retention projects, where the majority of the building is demolished and replaced with a modern new build structure, retaining only the facade from the existing structure. While this method resolves a great number of the issues inherent in such projects, by simply replacing the problematic elements and features with modern equivalents, designing an effective interface between what is replaced and what is retained can still be challenging. Air leakage and cold bridging are the most significant problems to be overcome in these areas, so by combining a vapour-permeable, self-adhering air barrier membrane with a layer of high-performance insulation, Wraptherm offers a simple and compelling solution to these issues. Wraptherm is installed on the reverse of the retained facade stonework in a similar way to many self-adhering damp-proofing membranes. However, as Wraptherm is vapour-permeable, it does not adversely affect the movement of moisture through the facade stonework. This helps limit damage that can occur when moisture flow through older stonework is altered, but upgrade works. As well as protecting the existing building fabric, Wraptherm's hydrophobic properties provide a secondary barrier to water ingress, and by sealing tightly to door and window frames and other penetrations, also limits heat loss associated with air leakage. The unique layer of aerogel insulation in the Wraptherm also effectively limits cold bridging by providing a continuous insulation layer across the back of the facade, so there's a thermal break between the new structure internally and the cold outer stonework, providing a further boost to the energy performance of the upgraded building. By combining these properties into a single material, Wraptherm not only speeds up and simplifies the installation process, but it reduces on-site defects and requirements for costly remediation. Spacetherm wall liner. While Wraptherm is focused on more extensive refurbishment developments, smaller scale projects can achieve the same performance benefits using the Spacetherm wall liner. This comprises aerogel insulation bonded to a durable 3mm magnesium oxide facing board and fixed in place internally using a gap filling adhesive. The panels can then be jointed, skimmed and painted and decorated in the same way as a normal plasterboard wall. It is supplied in a 1200 by 600mm panel weighing just 4.9 kilograms, meaning that sheets are easily handled by one person and can be easily moved to hard-to-reach areas or stored on site without affecting access. Once installed, the system provides a significant reduction in heat loss, with a minimal 13mm increase in wall thickness, meaning in most cases, sockets, switches and TV network points can be left in situ and features such as cornices and window sills can be left as is, with no modification required. It's often the case that meaningful thermal upgrades to older properties are ignored due to the cost and problems associated with such enabling works, and result in unforeseen added costs. Thin systems such as Spacetherm wall liner therefore offer specifiers and homeowners a simple option where traditional thermal upgrades are not possible. Even though this system typically won't achieve performance in line with building regulations, even a small upgrade in thermal insulation can raise the internal surface temperature enough to avoid condensation problems. The minimal thickness also allows it to be used on space-constrained areas to ensure continuity of thermal insulation. In our example here, a solid uninsulated masonry wall has a risk of condensation across the whole surface, both the main part of the wall and at the window reveals. If insulation is added to the main wall surface but emitted from the reveals, although the wall surface temperature increases, the surface temperature in the window reveals actually decreases, leading to an increased condensation risk in these areas. Even adding a minimal amount of insulation to the reveals will elevate this temperature by enough to mitigate the condensation risk, highlighting the importance of a continuous envelope of thermal insulation. A properly optimised thermal envelope design encompassing both the walls and reveals may also reduce the required thickness of insulation throughout the building. In addition to Wraptherm and wall liner, the high-performance Spacetherm Aerogel is available in a number of other forms. Spacetherm Multi uses a similar magnesium oxide facing to the wall liner board, but with an increased thickness of 6mm. This additional thickness allows the same board to be used in both floor and wall applications, making Spacetherm Multi a simple and versatile one-board solution to upgrading the thermal performance for all types of existing structure. Spacetherm Multi is available in both 2400 by 1200mm and 1200 by 600mm sizes, with the smaller size board being ideal for projects such as loft conversions where access may be restricted. The inherent moisture resistance of both the Spacetherm Aerogel and the magnesium oxide facings make it a great option for floors where the presence or condition of damp proofing may be unknown. Spacetherm wallboard and direct fix. Where a more traditional finish is required, Spacetherm wallboard offers a plasterboard finish with the same aerogel insulation as the multi-boards. This is fixed onto timber straps or studwork in the same manner as traditional insulated plasterboard, but offers significantly better performance. For applications where space is even more constricted, SpaceTherm Direct Fix can be used to omit the requirements for the timber strapping and its associated depth. This board incorporates an additional layer of plywood to facilitate the use of shot-fired fixings into masonry substrates. The hydrophobic nature of the SpaceTherm Aerogel insulation blankets means no additional protection is required on damp walls, making SpaceTherm Direct Fix a one-step solution to thermal upgrades on walls with moisture issues. Both the wallboard and Direct Fix panels are supplied with an inbuilt foil layer for vapour control. However, if the design criteria requires higher permeability, this can be omitted on request, giving a more breathable wall construction and allowing the free passage of moisture. SpaceTherm Cold Bridge Strip. Designed to prevent cold bridging through a component or element of a structure, SpaceTherm CBS consists of a SpaceTherm aerogel insulation encapsulated in polyethylene. SpaceTherm CBS is an ideal choice for timber or steel frame structures, and on request can be cut to a variety of widths to suit different applications. In addition to timber and steel structures, it can also be used in other applications where cold bridging is an issue. SpaceTherm Blanket. The SpaceTherm blanket consists of unfaced sheets of high-performance aerogel composite insulation. The possible applications of the SpaceTherm blanket are virtually limitless, as it has been used in doors, shutters, window reveals, boats, swimming pool covers, and numerous other applications where thermal performance, space, and thickness are critical. SpaceTherm Slentex A2. The SpaceTherm Slentex A2 range of laminates takes the high performance of the aerogel insulation and uses a carrier material with more limited combustibility. This sacrifices a little of the thermal performance, but takes the reaction to fire classification up to A2, giving an ideal mix of physical characteristics for applications which are both space limited and safety critical, such as limiting cold bridging in facade systems. Available in a range of facings, SpaceTherm A2 can also be used to internally upgrade thermally deficient residential high-rise properties without compromising on fire safety. SpaceTherm A2 is available as an unfaced blanket and also in the SpaceTherm Multi, Direct Fix and wallboard laminates. It can also be supplied in cold bridging strips. Hygrothermal assessment methodology. We've talked a lot today about moisture movement in existing structures, but how do we assess this and predict the effects of the refurbishment accurately? The BS 5250 and EN 13788 standards cover the assessment of moisture movement in buildings, and both have an important limitation which may lead designers to seek further guidance. Both standards rely on a calculation method known as the Glaser method, which was developed in 1958. Glaser uses steady-state heat conduction along with average monthly temperatures and the vapour pressures to identify vapour diffusion and model how vapour passes through the building fabric. This gives a reasonable assessment with a comparatively simple process and simplifies data input requirements. However, there are limitations. The main problem is that this method only models moisture vapour flowing from inside to outside and completely ignores the effects of external moisture sources, such as driving rain. The model does not incorporate the effects of material porosity, moisture absorption, and water storage in the building fabric. As stated in EN 13788, the method assumes built-in water has dried out and does not take account a number of important physical phenomena. The improved EN 15026 standard addresses these issues with the new calculation method based around dynamic numerical simulation of moisture flows. This type of simulation provides a far more detailed and accurate representation of the way in which moisture both flows and accumulates in the fabric of buildings, and is the method specified for solid walls with internal insulation in BS 5250. This more accurate simulation not only allows for greater variations in environmental condition and material properties, but also offers a more flexible approach to simulation time periods. Designers can look at minute-by-minute predictions on the building performance, taking many years into the future if required. This additional detail in time can often reveal small problems that can grow to cause severe issues over the years, issues which would be commonly missed by a simpler Glaser method calculation. The trade-off to use this more advanced method is more complex simulation software and outputs which are more complex to determine. At the A. Proctor Group, our team of technical advisors are trained to provide these simulations using the WUFI software developed by the Fraunhofer Institute, and we'll move on now to take a look at one of these assessments on a solid sandstone wall. Case study. In this case, we'll consider a typical solid existing wall with two skins of solid sandstone and a concrete rubble fill core. This is a typical traditional wall type found in many areas of the UK. However, in this case, we use environmental data for Glasgow and in the internal medium conditions defined in EN 15026. The model will be used to examine the performance over a 20-year time period to ensure any influence from construction moisture is eliminated from the assessment and a true representation of the as-built performance is achieved. We'll consider 4 different cases to upgrade this wall using Spacetherm systems. Firstly, the Spacetherm multi-system, with a thin 6mm magnesium oxide facing and no additional vapour control, giving a vapour permeable solution. Secondly, the Spacetherm wallboard, using a conventional foil-backed vapour check plasterboard facing. For both facing types, 10mm and 30mm of insulation will be used, representing both the bare minimum thermal upgrade and one achieving performance closer to modern building regulation standards. The first step in this assessment is to run the model with no insulation to determine which area of the building has the higher inherent condensation risk, to establish which represents the worst case. If the upgraded structure is modelled using this element, it can be assumed the other, less onerous elements will perform adequately. We can see from the graph here that the west elevation has the highest predicted relative humidity, and therefore the highest risk of condensation occurring. So having established the worst case scenario, we can now move on to a more detailed assessment of the wall construction itself. Here we can see the results of the modelling on the first case, 10mm of aerogel on a Spacetherm multi-board. The green line on the lower graph shows the relative humidity through the wall, and the blue line shows the moisture accumulation. In this, although both are higher than would be the case for a more modern wall construction, such as a cavity wall or timber frame, the moisture content is not increasing year on year. If we now increase the insulation thickness to 30mm, we can see the temperature gradient gets steeper through the insulation, but the relative humidity also increases as the inner surface of the stonework has become cooler. The moisture accumulation graphs are similar though, with no increase in water content. In the next case, we can see that by introducing a vapour check into the Spacetherm board, this serves to limit inward drying, increasing the relative humidity and actually increasing the overall condensation risk. The final case combines this moisture trapping effect with the increased relative humidity from increased insulation thicknesses, giving the highest overall condensation risk of all 4 cases. As can be clearly seen, the permeability of the Spacetherm multi-boards allow for a greater drying out of the construction, as this is possible to both the interior and the exterior of the building. This results in much greater swings in the value of the relative humidity, but the values are lower overall than when the vapour checking Spacetherm wallboard is used. If we then look at the water content of the stonework, this can also be seen to be lower when thinner and more permeable insulation is used. So, considering all of the above, the risk of condensation, counterintuitively, is lowest when we omit the vapour control measures and limit the insulation thickness. The additional detail presented in this more complex assessment also allows the designer to better quantify and hence manage the specific risks associated with this insulation upgrade. Case study, Bath Townhouse. The heat efficiency of a Grade 2 listed Georgian townhouse in the historic city of Bath is set to be dramatically improved as a result of the introduction of Spacetherm multi-insulation. The challenge of dealing with heating inefficiencies, major heat loss and heating costs are a common problem with many listed buildings and solid wall dwellings. Property owner Mike Moore obtained planning permission to insulate the top floor of this Grade 2 listed Georgian townhouse, as it is single skin 6-inch Bath stone and very heat inefficient. All walls have the original lime render and skim, so they need to breathe. The property in Bath was built in 1818 and has been in his family for 101 years since 1919, so it needs some serious upgrading. The project was initially specified utilising 100mm of conventional insulation, necessitating moving door frames and rebuilding window reveals, as well as a fair amount of lost floor space. Mike's research led to Spacetherm, however, and working with his architect, he was able to reduce this to just 20mm using Spacetherm Multi, reducing the associated disruption while still delivering a meaningful thermal upgrade which was acceptable to both building control and conservation officers. A lime plaster finish was applied professionally by a contractor upon completion of the installation, complementing the permeability of the Spacetherm systems and protecting the original stonework. Finally, Mike Maurer commented, "I think Spacetherm Multi is ideal for a listed building insulation as it has a minimal effect on the infrastructure of the original building. It has the potential to be used extensively in old buildings, such as we have in Bath, where heat loss is at a maximum. The original walls need to be able to breathe when insulated, and I'm also seeking planning permission to use the product to insulate the basement floor and walls." So we've seen how effective modern high-performance insulation can be, but also how carefully we need to consider the effects and implications of anything we do to upgrade older buildings. A lot of this has been very project-specific, and our technical team is able to help specifiers assess and mitigate any problems before they arise. With that in mind, as we move on to the Q&A session, it may be that we need to follow things up by email and run calculations more than would normally be the case for these webinar sessions. We still have our full range of technical support services available right now, so where we can help, please ask. Over to the questions. Good morning, everyone. Thank you all for joining our webinar this morning, Aerogels and Building Refurbishment. I hope you find it educational and interesting. I'll just go over some general information and introduce people, and we can start the question and answer session this morning. There are personalised CPD certifications available. If you go to proctorgroup.com/webinar-certification, you can get it there. I believe the link is also in the YouTube description. If you have any problems, email us. You can email any questions you have regarding the session to inquiries@proctorgroup.com or reception@proctorgroup.com is our more familiar one, and also post on the live chat if you have anything. We're committed to doing webinars every Friday morning at 10 a.m. during lockdown and maybe beyond, because they've been going well so far. So next week we have a webinar on heat, air and moisture movement. Predominantly I think it's lends itself to commercial buildings, but it will cover the general concepts as well. So that's a really interesting one. And the week after that, on the 1st of May, we'll be live with impact and airborne sound solutions for floors. So depending on the type of projects you're involved in or what you're interested in, you may want to join all, none, some of them, so feel free. You will receive an email after this Q&A session, which has a replay for the webinar. Feel free to circulate it far and wide. You know, if you feel that colleagues would be interested or others, please feel free to send it on. I think that's the general stuff. So if people can give a quick wave as I introduce you, because there are three, I think your names are on there, but just in case. So Callum is our technical sales advisor based in the office in Scotland, not today. He's at his home in Crieff, which is a nice part of the world. Adam Salt is our technical regional sales manager, talking to us from Bristol. And is, hi Adam, our London specification manager, based in London, obviously. So we've actually received a lot of questions over email, and I can see some have come through on the live chat now. So a few comments that we had after the last webinar was it was a bit long at the Q&A session part. So it's just to say, you know, in British style, we don't want to leave things until they're finished. If you have another commitment and you need to go early, we won't be offended. We can't say who's leaving when, but we do want to keep this open to answer all the questions that have come in. So we'll just keep it going as long as we can. So we won't be offended if you go early. And equally, if you can stay and you want to listen to all the questions that are being asked, please feel free. So I will just crack on with some of the questions that have been received via email and then start going through the live chat as well. The first one, Callum, maybe you can take this one, quite a general question. How does Spacetherm compare to other insulations?
Okay, so Spacetherm is a lot more thermally efficient than most insulations. It was explained in the webinar earlier that it has a thermal conductivity of 0.015. That's compared to about 0.022 for a PIR or 0.04 for a mineral wool, and with the lower number being much higher for an insulation. This means that for a situation where you need about 50 millimeters of a PIR, you could use about 35 of our space therm, which results in a huge saving. It's also the system itself is also smaller because we use smaller boards than typical installations. So where a standard system might use a 12.5 millimeter plastic board, some of ours use only a 3 millimeter magnesium oxide board, so you're saving about 9 millimeters there as well.
Okay.
It's also smaller because rather than being applied to battens or between battens, it's most often applied directly to the wall. This means that where you'd have a typical solution of 25 millimeters of battens, 50 millimeters of PR, and 12.5 plasterboard, which would be about 87 millimeters, you could do the same in about 41 millimeters of our space thermal, and that's 35 millimeters of insulation and 6 of the magnesium oxide.
Great. Okay. So to summarize, so generally, of course, the thermal conductivity is much improved, and the overall space. Is that someone's dog? Is that your dog, Callum? I can hear a dog.
It's not my dog.
It's not your dog. Someone's dog's barking, I think, unless I'm hearing you. And you can, it could be, at least it's not my cat today. So you can reduce the overall space depending on the different finishes that we supply with the space therm. Great. Okay, Adam, does cutting space therm on site generate silica dust? And if so, what PPE is required? We just quickly, we've had a couple on this, so you might want to go into the best way to physically cut the material on site as well, Adam, if you don't mind.
Okay, well, mechanical cutting is best done with a jigsaw or circular saw, preferably with dust extraction, over a plastic sheet to contain the dust. We do recommend covering up with appropriate PPE, as space therm can produce dust when cut. Therefore, when available, I recommend cutting the boards outside. What is also a good option is we can cut in our factory to the exact sizes that you require. So if you have a certain window reveal, for example, or a width of a cold bridging strip along timbers or steel, we can cut those exact sizes for your project. Reduce the amount of cutting done on site. So yes, it does produce dust, but take precautions. Okay,
good. One from James McGregor. Callum, this is a WUFI based one. Obviously, that's your skill set, something you do a lot of for us. What are the differences between WUFI calculations and the traditional Glaser method in terms of inputs and results? Do they show a difference for typical wall construction when space therm is added?
Yes, they do. So you explained it very well in the webinar earlier. In a Glaser calculation, it does only consider one directional vapor movement from inside to outside. And so having a vapor barrier in front of that would always show no condensation in a Glaser calculation. In reality, though, you do have bidirectional vapor movement. The stone itself will be moving stone by diffusion and capillary action. And so this could actually build up behind a vapor barrier on the inside face. So that's where WUFI is more appropriate to show that there is a more dynamic moisture movement in that scenario.
Okay, good. Did you have something to add there, or?
I would say that the British standard 5250, which determines the control of moisture in buildings, recommends assessment per the standard that influences WUFI, the 15026, rather than in the Glaser method for a solid wall.
Okay, good. And just while we've got you, Callum, and it's on WUFI, Stephen's asked if we charge for WUFI calculations. Now, correct me if I'm wrong, the answer to that is we don't charge, presuming there's a specific project or something we can help with that would be related to something Proctor, is that right?
Yes, that's right.
Yeah. So of course, WUFI calculations can take many hours, and they are very complex. So we do have a technical team that are fully trained in them. But of course, we're not a service. We are a business which is selling product and product solutions. So, but we would be able to look at these individually for your projects and advise. I don't think we've said no to doing a WUFI calculation yet, but we do like to make sure there's something suitable. Okay, James. With the A2, so this is a question from Sam that came in via email quite early on. With the A2, if you bond the boards together, so be it insulation, plasterboard, or MGO using glue, does the system still achieve A2?
In essence, it's about calorific value because you're putting an organic compound, i.e. the glue between the boards, whether it be bonding the A2 boards together or whether you're bonding a finishing board on the face. Yes, you are putting in a calorific product within there, so there is a fire risk, but due to the sort of a very low calorific value of that glue, inherently the product will still maintain its efficiencies.
Okay, great. One from James Carrott come through on the live chat. Where the existing building already has insulation within the central core and more insulation is added to the internal face, how do you address interstitial condensation and dew points? Is that one, Callum, you want to take?
Sorry, could you repeat that, please?
Yeah, sure. So where the existing building, the existing building is already insulated within the central core, and so more insulation is then added internally, so the space therm applied internally. How do you address any interstitial condensation risk and dew points?
That would have to be something that's assessed on a project by project basis. So if there's a specific project, then please feel free to contact us. Generally, I would say that as space therm is vapor permeable, and if you would be adding a very thin layer of insulation, it doesn't add much to the risk of condensation. But as I say, it would be project specific. So
okay, great. There's two installation questions here, James, if I can come to you, if that's okay. The first one's from David via email, and I'll just ask the second one at the same time because it's quite relevant. So do you have specific fixing details for your wall and WRB boards? And the second one, from David on the live chat is how is the direct fixed panels fixed back to walls? So is it done using a bonding grab adhesive? And how does could that potentially adversely affect the aerogel layer?
Okay. With the window reveal boards, what we generally stipulate is if you're using a standard window reveal boards with the plasterboard on, then you'd utilize drywall screws to mech fix the board back to the substrate, making sure that the screw is 25 millimeters longer than the thickness of the entire product, obviously with the plasterboard and the aerogel on it. You can obviously, if the substrate is of a decent quality, obviously all the devil is in the detail. Everything needs to be pre-planned prior to installation to make sure that the substrate is of a decent quality, the mortar joints aren't blown. If you can obviously repair any of those areas, if they are blown, then it will make the substrate more substantial. But as I said, if you want to direct fix back to that substrate, then you can utilize the shop fire fixings if you're using an MGO board, whether it be 3mm or 6mm over the top of the substrate. But ultimately, best case, what you want to do in the window reveals is to make sure that you're not impinging on the opening at all, because otherwise you'd have to change the window or adjust the glazing. And in the same principle lies on a main wall system. Dependent upon the substrate, you either utilize DPC with a batten and then mech fix into that batten. It's not to impinge on the stonework itself or the blockwork. Again, reversely, if you're hanging anything internally, so like a kitchen unit or a television or anything on that sort of line, you don't want to directly hang it off the boards. You want to hang it off a structure that's built onto that wall. So if you know that the kitchen units are going on there, what you can do is put a battening rail system up behind the aerogel and MGO or aerogel and plasterboard system, so that you know exactly where those fixings need to go so that the whole process is robust.
Okay, perfect. And just while we're on the installation, Adam, maybe you can answer a question from Joanna. She's asked two actually. First one was, does it need special installers?
No, it doesn't actually. I had a case study in Bath, which was a grade 2 listed building, Georgian townhouse, and the client himself, Mike, did the install himself. And he was a musician, so you know, it's easy to install yourself. But I would always recommend he did his research into the product. We obviously have install guides on our website, and I would make sure you're comfortable with what you're doing before you attempt to doing it. But if you know how to install a standard insulated plasterboard, you should be able to insulate in the same way with space firm. So.
Okay. Okay, the second question from Joanna was, how would it be finished?
So I would recommend a lime plaster, obviously to continue the breathability through that construction. But if you're using a vapor control layer within the system, you could use any plaster as a finishing on top of the magnesium boards. But it depends on project by project. You might just be buying the blanket, using the blanket, and then you'd want to obviously bond on your own finish system. So
you're straight, sure. Well, that actually answers Adam Vaughan's question again in the live chat. I'm trying to keep on top of these. So for older buildings, do you need to use a lime base skim, or gypsum skims okay? Well, mind you, he is referring to being specifically in older buildings. Is a lime skim or gypsum skims okay?
I would always recommend using the breathable options in those projects, because you want to keep that breathability through to reduce the condensation risk. Or also you could get as explained in the webinar, the outside of the construction could be cold enough to get wind-driven rain cause a freeze-thaw effect on the outside of the building. If you're doing a Georgian property in Bath, you don't want to be damaging the front of the property, where it's got those lovely architectural features. So, yeah.
Good. And could you also answer, Adam, what's the difference between an MgO board and a plaster board?
There's a number of advantages. Magnesium oxide boards are much stronger than plasterboard. So this allows us to use a 3 mil or 6 mil magnesium board, whereas in other insulation systems, you may require 12.5 mil or possibly even 9 mil. So you're saving on that thickness, which again is the benefit of the product. There is also the benefit of breathability. Magnesium oxide boards are much more breathable than plasterboards. Although Space Firm is one of the best products for retrofit of solid walls, not only because of its low thermal performance, allowing for a thin solution, but also because of its breathability. So in that wall construction, you want to continue the breathability with your internal finishes. So that's your magnesium board, your lime plasters, etc. So that's why we prefer to use magnesium board.
Okay. Thanks, Adam. Just again, I'm trying to kind of group these, a couple of substrate questions. James, maybe you can help us on a couple about plywood. One of the questions is how permeable is plywood? And the other question from John, so that was a question from Paul. John has asked, if you put plywood into the build, that must negate the A2 rating. So one about the permeability of it and one about the fire performance.
In regards to the permeability side of things, in our WUFI calculations, the product that we utilise is a 3 mil cross-ply laminate, which has been investigated and tested by the Fraunhofer Institute, who created the software and run the software and all the data for the WUFI analysis program. The porosity of that is 0.56 cubic metres and the vapour resistance of 203. Obviously, as Callum mentioned earlier, we run everything by project basis in regards to the WUFI analysis. So if you are looking at, or if you require a thicker plywood built up in the system and you're going to build that system up yourself instead of using our sort of pre-bonded system, then that's absolutely fine. But what we'll do is we'll carry a calculation based off of those materials. So if you choose to use a WBP as opposed to an OSB or anything on that sort of line, then obviously we'll take the components of those products and obviously input them into the WUFI analysis and get it sorted from there. With the WUFI analysis, obviously we will instruct you whether there is a condensation risk or interstitial condensation risk, and therefore try and alleviate that problem with you. As mentioned, obviously in the CPD, you've got the ability to remove that VCL. You've got, if the requirement is there. If you're creating a condensation risk, we will remove that VCL that you on the back of the plasterboard in order to make sure that there's no interstitial problem. So whichever way you look at it, we'll always make sure that you've got the right option and the correct option, not only for a year, as per the Glaser method, which stipulates on a 12 chart, if your lines cross within that first 12 months, then you've got the issue. We will take it for 5, 10, 15, as far as your client needs it to go, we will take that analysis. Because what we found in the past is that not only does it, the condensation risk doesn't appear within the first year, it may manifest over a few years and then come out through the internal finish of your wall. But it wasn't stipulated at the beginning. Because of the WUFI, we can predict how that wall build-up is actually going to function in the future as well. In regards to the plywood in the build-up, negating the A2, indeed timber is a combustible product, but ultimately, sorry, you've got products in front of that plywood, which are A2 rated, A1 rated, which will negate the fire penetration through that product into the timber. And hopefully, obviously, if there is a fire, then the fire services will turn up within the time period allowable in order to make sure that it doesn't create a problem for the product.
Okay, good. Just going back to live feed, there's a couple of questions on cost, which aren't always the easiest to answer, but we don't want to avoid that question because we obviously know that Aerogel does have a reputation for being an expensive material. So let's ask our salesman, our technical salesman who's available. Do you want to kind of clarify the the question around the cost of the material? Are we looking at ways to try and bring that cost down? Is another question that's been asked.
Thank you. Well, Space Firm is not the cheapest of insulations on the market, especially compared to those more commodity ones that we're used to on the market, such as PIR and the mineral wools. So Space Firm is expensive, but I think as pointed out in the webinar, the product benefits projects where space is at a premium. Therefore, in the right areas, Space Firm can be cost effective. I work in Bath, which is very tight. There's lots of projects in London and city areas, especially where those spaces are a premium and a cost. So it's hard to put a figure on it, but especially as we have a number of different solutions as well. So if you get in contact with your projects, we're more than happy to look in detail and price accordingly for those projects. We are obviously trying to build up the reputation of it and get more projects under the belt as well. So I think in time that will only benefit the product.
Yeah, and in terms of the question, I'm trying to find it here, sorry. There was one about, what's being done to try and bring the cost of Aerogels down, so I can't locate it right now. I mean, to be fair, it has been a material used in the construction sector for sort of 10, 12 years now. So hopefully, again, in time, and that still class is relatively new because it is very niche in terms of the applications that it's put into. I mean, economies of scale. So in terms of the increase in production of this material will bring costs down in time. It just depends how quick and what that demand is from the market. So we're certainly seeing increases year on year. Different project solutions where space is critical. So you'd like to think that in time the cost for aerogel materials will come down, essentially, in the world and in the UK. Okay, Callum, I've kept you quiet for a little while, so we'll come back to you. Will Space Therm wall liner solve issues with mold and condensation?
It can do. There's no blanket solution for that. If it's an issue with surface condensation, then raising the temperature of the surface, so by installing an insulation in front of it, will definitely help. Space Therm wall liner being applied directly to the wall means that there's no cavity behind the insulation. If there was a cavity, then there would still be an interface for mold to occur on, so you could just be masking the issue with a battened off system. Mm-hmm. Space Therm has also been proven unable to support mold growth, so it does resist that.
So the hydrophobic nature of it, so in terms of how it repels water as well, of course. I mean, what's interesting, one of the things that we do during meetings with new customers is you can actually dip this material in water and take it out, and essentially it drips off, so it completely repels water. And we've immersed it in a bucket of water for days and taken it out, and it has not absorbed any water. And of course, mold growth, one of the biggest challenges is where you do have damp materials, and that is a great place for mold to form. So the kind of nature of this material stops that from happening anyway, doesn't it, Callum?
It does, yes.
Good. And a question, Callum, if you can have a think about this one as well. CE certification, Agreement Board, what kind of certification does this product have, our product?
So it has LABC certification, so it's certified by the building authority. That's really all it has, but it doesn't really come across many barriers that need more than that.
Good. Okay, that's great. Here's one about camper van conversions and shipping containers. Now, we have supplied these applications, but the question is in relation to, can you recommend use of it directly onto the metal?
Yes, that has been done in the past. We have done a wide range of one-off projects. So it's even been used on yachts for cool boxes. Yes, directly onto the metal would be a possible solution. It does depend on which of our thermal laminates you're using and what the van's being used for.
Okay, good, thank you very much. Stuart Thompson has asked, could you possibly advise if the aerogel products can be deconstructed and reused at their end of life? So again, that's an interesting question, which if anyone wants to add to, but I'll attempt to answer that one. We've been involved in a European-funded FP7 project going back a number of years, which actually talks more in relation to utilising the wastage from our product space therm or aerogel materials. So in terms of actually, again, deconstructing that and then forming it into some kind of blown fibre for new applications. So that's something that hasn't been commercialised, but trials were successful. So that's one way that obviously you could break that material down and reuse it. Again, Cal, maybe that's one you can answer. I'm not aware personally of any other ways it could be deconstructed and reused. It's not something we've done a lot of work on other than that European project.
No, it's not something that I've any experience in.
Yeah, I mean the material, it wouldn't be described as volatile, but the dust and the way the things that give it its characteristic can make it more, the handleability more difficult of it. So I'm not entirely sure, but it's a good question. It's something we should be thinking about going forward, certainly. Okay, there are still more questions. So Adam, do we have any case studies? Karen has asked, do we have any case studies of space therm being used?
Yes, we actually have numerous ones, which we can send out to you or you can find on our website. I think I mentioned it briefly earlier, but one project I was very lucky to work on was the Grade 2 listed Georgian townhouse in Bath. The property was built in 1818, and his family, Mike, owned it for over 101 years, and he decided to refurbish it because it had 6-inch single skin bar stone walls, which was obviously very heat inefficient. He was looking at a number of solutions where the thickness was much greater than the space firm option, and obviously the loss of space internally on his floor space would have been an issue. So he did his research and ended up using a total of 20 mil thickness onto his walls. So that was made up of a 10 mil space firm blanket, 6 mil magnesium oxide board, and then the render, which was a lime plaster to maintain that breathability. He only lost 20 mil in every wall, which was much more usable than any of the other solutions he was looking at. But yeah, a number of them can be found on a website, literatures. We also do a lot of magazine coverages, and you'll find case studies in them as well, like Specification magazine as well.
Okay, good. I'm just going back to the live chat. I seem to have skipped a couple of questions. Callum, again, maybe a good one for you. Is the K value of 0.015 a lambda 9090 value?
I'm not sure on that one, sorry.
Okay, so if we come back, if Adam can send that through to technical@proctorgroup.com with your email address, we'll be able to come back to you on that particular question. The other one we may want to come back to is Stephen Marshall's, our thoughts on the use of MGO following the NHBC guidance outlining the use of it. So I'm not sure whether that NHBC guidance lends itself more to new build applications. But is that one you can answer, Callum, or would you like to have a think about that?
Yes, it is. So that's to do with the silica content of the MGO board.
Okay.
Not the silica content, the is it the calcium silicate content? It's to do with the salts that form on it. The issues come from a few projects, specifically in Denmark, where MGO boards were used as a sheathing board, and salts formed as a result of water content leaking. Our boards have been tested not to have such a high content, and so they don't. They're also used internally, so it's a different application.
Okay, good. A couple more application questions, James. I don't know, I keep coming to you for these, but the first one, and then I'll come onto the live chat again, from Carol via email. Can space therm be used in basements?
Yes, I mean, as we've mentioned quite a few times, the hydrophobic nature of the product lends itself massively to that sort of installation, especially in a basement area. You're going to be looking at confined spaces as well. So having the high performance thermal properties of the product is great for that application. All I'll say is needs to be very mindful, obviously, that inherently the build-up in a basement area internally will be a lot larger, purely due to the fact that you've got to take in mind your water table in the existing substrate outside of the building envelope, and you've got to be very wary of hydrostatic pressures from the water trying to sort of force its way into the building through the blockwork, through the brickwork. Having that cavity behind there, so having a standalone wall with the space therm on will be the better option, because then you can put your delta membrane, or others are available, within that cavity in order to make sure that any water coming through that existing blockwork or new blockwork will drain down into the cavity and off in the correct manner. But yes, the product can be utilised, and it's an ideal product to be used in that area.
Okay, great. And there's a flooring question, if I can just find it here, sorry. James has said, I did hear that space therm can be used to insulate floors. We've had a number of projects with that. If so, again, this might be more project specific, but if you can answer it, do please, James. What minimum thickness does this add, and can it be used on top of asphalt?
On top of asphalt, in regards to roofing or flooring?
Or flooring, yeah. Unless it's two separate questions.
Yeah, I mean, from the point of view of a floor aspect, yes, it can be. Obviously, if you're looking at having some sort of underfloor heating, generically speaking, you'd require a reflective layer on there in order to make sure the insulation didn't absorb the heat. You want the foil facing to reflect it back into the building. But yes, if from a retrofit purpose, having 10 to 20 millimeters of the space therm product on your deck, whether it be concrete, whether it be asphalt, which is a new one on me after 20 years, I have to admit, on the floor. It's more than adequate to do that. But again, project by project basis, we'll carry out the analysis on the project. We'll need the square meterage of that floor area and the perimeter of the floor area as well, in order to carry out the required details. And indeed the floor finish. Because what we can do, yes, you can utilise the blanket, but what we'd rather do is utilise the space therm multi, which has got the 6mm MGO board on top, to give you that resilience layer as well. Roofing's probably another conversation, but yeah, that's fine.
Okay, good. Adam, just coming back to the case study you were talking about and that was in the presentation, the Bath townhouse. Darren's asked, as an example, the overall wall U value, what was it? Someone you know off the top of your head?
I believe before we put any insulation on, it was around 2.1 U value. Then when we put the 16mm on, it went down to 0.8, which I think roughly is about 61% heat loss reduction.
Okay.
So that's obviously a good example. I don't know those exact figures, but it was around those sort of figures.
They sound good, that. Good memory if you're thereabouts. Well done.
I have the project here, but yeah.
Good. Okay, so let me just check here on the live feed. I do have a couple more via email, so we'll just again keep this channel open and keep asking until these guys are exhausted. Rob's asked a question regarding modular building systems. Are there any other considerations when applying aerogel products to modular building systems, e.g. galvanized lightweight steel framed buildings? Trying to think who's got experience in that. Maybe Callum or James, would you be, or Adam, if anyone's happy to answer that one?
Could you repeat the question, sorry?
Sorry, yeah, I'll try and read it a bit more succinctly, if I can find it. Are there any other things to be considered when applying aerogel products to modular building systems, e.g. galvanized lightweight steel framed buildings?
And just like with anything, when you're fixing anything to any substrate, taking into consideration the volume of penetrations that's going into the product, because obviously that's creating a thermal bridge between that external skin and the internal. making sure that you sort of speak to a manufacturer of fixings to get the appropriate fixings for that installation. Otherwise, obviously, your service void, I suppose, in regards to what pipe work you're putting through there, what electric systems you're putting through there, and just making sure that everything's pre-planned in regards to that. But ultimately, again, I imagine from Callum's point of view, it's literally project by project basis. If you've got that particular, if it's a corrugated skin, if you're looking at converting a shipping container or something on that sort of line, then you've got that undulating external leaf. So it's worth sort of making sure that everything's done properly. Obviously, again, we've got the instant stick adhesive, which can be utilized to bond the product back instead of using fixings. So it may be utilizing the fixings where you're putting your service products into that cavity, but we'll work with you and specify exactly what needs to be done in order to achieve what your TER or DER is.
Okay, good. Just coming back to the container question we had, if that individual's still there, we have a great case study on that where we actually re-insulated a project called District 10 up in Dundee, which if you drive past, it's a really interesting building, which is containers that have all been converted into offices. So again, if you email us, we can send you that case study, or it is on our website. So if you look on the Space Therm projects, it will be down there somewhere. I think it's District 10. Was that a movie? No, I think it is. I think it's both.
Yeah.
I think it's definitely the project name, and it is quite a bad movie from memory. So great. Okay. Just having a look here, aerogels are not only advantageous from a thermal point of view, but also acoustics. Is A Procter developing any specific acoustic beneficial products, such as acoustic battens? We are aware of the acoustic benefits, and we can probably talk through those in more detail. In terms of battens, it's not something we've looked at, I think perhaps because it's cost prohibitive. So at the moment, of course, there's different foams, and we actually have a number of new developments in the pipeline for acoustic product solutions. But I don't think we do. Is there anything you want to add, Callum, in terms of the acoustic benefits of Space Therm that we're aware of?
It's not really something that we've done much testing into. As you say, it would be expensive to use as an acoustic installation. For acoustic installations, you generally want more mass. So if you're doing a lot of mass in Space, then it would build up the price quite quickly. Right.
Okay, but there are obviously acoustic benefits which can be applied to the wall or the various different projects it's being utilised in. Okay, James, if we come back to you.
Yeah.
Matthew's asked a question, does the WUFI result base its result on a penetrated VCL?
Yes, what we'll do is we'll, not necessarily a penetrated VCL, but what we'll do is we'll carry out two analyses for you, one without a VCL and one with a VCL. So basically, you technically you're covering the fact that a VCL would be penetrated by not even involving it in the process. So yes, we cover both areas. Again, as I alluded to earlier, we'll never steer you down the wrong path. We'll never steer you down a more expensive path than required. We'll steer you down the correct path for the build-up itself that you provide us with. Obviously, if ever that build-up changes, or indeed, especially in the regards to the humidity class within that property, if that changes, if the use of that room that's directly connected to that wall changes and it becomes a shower room or something with a high humidity class, which obviously, as I'm sure you're aware, ranges from 125 up to 44,000, we will take that into consideration for you.
Okay, good. Adam, I'm just going to ask you another one from the email quickly, and then I'll go back to the live chat. It's great that we're getting so many questions, so please keep them coming. One from Chris specifically about the Space Therm cold bridge strip. So I presume he's either used this or has experience of it. They're sealed in the plastic casing, which is true. Does this affect breathability?
Yeah, so the Space Therm cold bridging strips, they are sealed in plastic. Case that obviously allows ease of install, and it allows the adhesive strip on the back to stick on and then peel off again. With it being such a dusty product, it can be speed up the production, especially if you're doing a number of timber frame houses or steel frame houses where you've got a lot of cold bridge strips to be used. Just speeds up the time. But also you've got to remember they're being applied to steel and timber, which are also not as permeable as the insulations and airspace, which would be adjacent to them. So you would probably have measures already in that construction to handle the impermeabilities of them, as well as the cold bridging strips. So yeah.
Good. Okay. Thanks, Adam. An NGO related question, Calum, if I can come to you. From Peter Cole, magnesium oxide boards have a smooth and a rough side. Are they always breathable?
There's a wide range of magnesium oxide boards on the market. Most of them are fairly breathable. The ones that we use certainly are.
So we could really, presumably we can't really comment on every single MGO board, but the ones certainly typically that we would bond our Space Therm 2 or use in different applications would be.
Exactly, yes.
Okay.
Also on the rough and smooth side of it, the abrasion of the surface wouldn't make any difference to the breathability.
Okay, good. Thanks for that. Something I'm not particularly familiar with, so again, I'll put it out to the three of you if any of you have experience. So Mike's asked, is affordability a real issue when weighted against whole property retrofit costs moving forward to PAS 2035? Something that we're familiar with, or is that a question for email that we would ask for, I think? I think, well, maybe based on the hesitation, we would have a look at that one over the email and come back. That's fair. We do have a larger technical team, so someone will be familiar with that, presumably guidance, and come back to you. Okay, Giles has asked, is Space Therm classed as an inert, non-hazardous or contaminated waste in terms of disposal in skips? Again, something we'd need to check.
From the point of view of the product, it's 0 ODP, less than 5 on the GWP. It is sort of it's non-hazardous to human health. Obviously, from the cutting point of view, we do advise, obviously, as Adam said earlier, to wear full PPE if you are cutting on site and have a ventilated area. But again, in regards to the waste side of things into skips, I think we'll have to have a look into that and see what we get from it.
Agree, good. I mean, I still feel it's good to ask these questions, and if we have the answers, we will answer them. We do this as a business across all our product ranges. If we don't have the answer, at this moment in time, we will go and find it. Technical director, different individuals have different skill sets in the organization. Okay, from Carol, if you were to be internally insulating a standard solid brickwork wall, what thickness would be required to achieve the building regulations target U value of 0.3?
It would be about 40 to 45 millimeters, assuming it's a standard 215 millimeter brick wall. We can do these calculations on a project-specific basis if you'd like to get in touch. But 40 to 45 millimeters would be a good guess. Great, and it's worth noting. Sorry, but a sales and technical plug here, that in our members area on our website, which we've launched prematurely, well, we launched it earlier than we had expected to because of lockdown. There's lots of people looking for different information. We will be adding a U-value calculator facility online to that members area in the coming weeks. So please keep an eye on it and register now, and then obviously you'll be updated when that comes live. We've done a lot of work in-house on that. Okay, let's just keep looking through here. Adam, maybe you can answer this one. Can you tell me what thicknesses the blanket is available in? Thinking about integration, well, Andrew's obviously considering integration into window shutters, sash window cases, and door panels.
Yeah, well, we can do a range of thicknesses, really from depending on what we need to achieve. Normally in 5 or 10 mil integers, but yeah, it just depends on sort of what the project is. We can also, as I said before, we can cut them to different sizes depending on, if you're doing a window reveal when you don't need a full 2.4 by 1.2 board, then we can just do the exact size you require. So yeah, it varies again from project by project, but a range of sizes, we can go up to over 100 mil thick as well, if required.
Good, okay. And actually, here's another one, Adam. So Lawrence has asked, would he need to insulate reveals if he's doing the main wall areas?
Okay, so there's a common misconception that the reveals are not important to insulate as long as you've done the main areas well. But there's actually been research which shows heat loss in a wall with 140 mil of insulation and no reveal insulation is actually equivalent to around 60 mil of insulation on the walls, with the reveals being insulated as well. So by doing those thermal bridging areas, you can actually reduce the thickness on your walls. So they are just as important, and also could be more cost effective in your projects. So definitely take into consideration all the thermal bridging areas.
Okay, great.
I think, one other point, I think we're working on some information paper. You'll probably know more about that. That'll be coming soon based on that topic.
Yeah, we are, yeah. So hopefully that'll be ready for issue shortly. Something else. What we're trying to do is do a lot of sort of in-house work at the moment whilst there's less meetings, and try and provide as much information as we can. So you're right, there's information being done on that. Okay, there are still questions, so I'm going to keep asking. We've got sort of 4 or 5 left. Callum, Ingalls has asked, how would it be used to resolve cold bridges around steel joists or columns? So this is kind of linked to your earlier question, Adam, on the cold bridge strip, but can you be a bit more specific on that maybe, Callum?
Yes, so as Adam said, we do offer it as a cold bridge strip, which is wrapped in polythene, so that's an excellent solution. But you can also wrap the entire steel in our space-therm blanket, so typically this would just be tied on or mechanically fixed. You could also use WrapTherm, which would include our wrap tight, so that gives you air tightness at that junction as well. So there are a number of options.
Okay, good. I mean, it's fair to say we obviously have a lot of experience, in steel and pipe sections from our business in the oil and gas sector. And certainly when it comes to the steel joists and the columns, that's where the space therm aerogel is applied in the sort of more commercial type buildings. So again, if you have sections that you want us to look at, these can be prefabricated at our end and then sent out to site to save time and cost, etc. So please get in touch with the technical team if you do have anything. James, this is a question from another Derek. In the internal surface, if the internal surface is painted, so i.e. if you have an existing wall and it's got multiple layers that have been put on over the decades, will it still be breathable, and can the expanding adhesive adhere to it? So I guess they're talking about the wall liner here, going on to directly onto the wall.
Yeah. Again, it's a good question. The devil is in the detail as always. Yes, a painted wall, especially one that's had multiple layers on over decades, or if it's a sort of historic building over the centuries, then yes, it will affect the breathability. So ultimately, as you would do with an unknown, is in regards to the adhesive, is you look at doing a small sort of test area first of all to see if the bond is there. Again, if the bond is good, but you sort of want that security, then obviously you'd mechanical fix as well at the same time. In regards to the breathability, yes, paint will affect the breathability of the system, but ultimately that paint was there prior to the space therm being fixed to it. So therefore, if there was no issue in regards to condensation or moisture, and it's literally a thermal upgrade, and there's no mold growth or any water damage on that internal leaf, then you know that system is functioning properly. But ultimately, again, if you can take that paint off, if you can take it back to the substrate, then that's ideal. But if you don't want to do that, then please carry on and fix the board over the top, and putting the board won't impede the vapor permeability of the system.
Okay.
So breathable now, it will be breathable in the future. If you've got water damage or mold growth, then you need to do a little bit more investigation into what paints, or even take it back to the substrate.
Okay, a bit more investigation before you put the serum on top. Great. A question here for Mike. So, so when does Aerogel's patent run out? Is that the only time we can expect to see real-time cost reductions and competitiveness when it comes to mainstream cost? I mean, Mike, our partnership with the manufacturer of the Aerogel product, they would hold the patents on these materials. It would be inappropriate for Procter Group to comment on any intellectual property, when that runs out and what's in place. But I mean, you could be right. It could well be in due course. There are other manufacturers out there who are producing aerogel-based materials. The raw materials price will fluctuate based on supply and demand. So I explained that we obviously do work in oil and gas with a different type of aerogel-based materials. So again, different markets can dictate different production schedules for the different manufacturers that make aerogels, and that sometimes can affect prices with supply and demand depending on the sector it goes into. So to summarize, I think it's a good question. Like most things, if there's patents in place, they tend to be more expensive because there's less of them around by default. But specifically on the dates and what's in place, that's not something that we would be able to commit to commenting on. Tim has asked, if used in a flooring application, what about compression and subsequent reduction in R value? Looking at Callum. You can't see me looking at you, Callum, but I was looking at you. Is that one you want to take?
It is a compressible material, so there would be some compression, particularly at greater thicknesses. For the most part, it wouldn't reduce the thermal performance significantly.
Okay. And is that something you could be more specific on if given an example or more details, for example?
Yes, it is. So if you give us the project, we can work out what the U value would be, and we would advise on how thick it would need to be to avoid being too compressible.
Okay, good. A couple of questions through email, but they're actually more for answering after the webinar. So I think I've got two more, which I'll ask before we kind of draw to a close. If anyone has any that I've missed, I don't think I have, or any more to post, please do that now on the feed, and we'll happily stay as long as you like, as long as it doesn't eat into our lunchtime. So we've got as long as you feel free to post them. So James, this is another question on WUFI, which I think you'll be able to answer. Is WUFI updated regularly with material performances and capabilities, so i.e. not data from the 1940s?
Yes, indeed. I mean, obviously, the Fraunhofer is a business, and it's looking at sort of future-proofing itself. It works very close with manufacturers. I mean, as with our products, we give all our information over to the Fraunhofer Institute so they can update their software. And again, with new and befangled products that are coming out, then that data will go in there as well. From the innovation in the country, from the innovation in the world, there's multiple different products out there. So therefore, that information, if needed, will be sent to the Fraunhofer Institute so that they can load all that product information in there. As sort of said in the CPD in regards to the porosity, absorption and retention of water, the products within your existing build-up is taken into consideration as well, whether it's sandstone, limestone, whatever it may be, whether you've got your lime mortars instead of your standard sand and cement mortars that are out there at the moment. The Institute takes into consideration those products and the absorption, retention and porosity of those products. So it's a constantly evolving, as with the weather data coming in from the satellite in regards to, apologies Kira, Storm Kira and Storm Dennis that were here earlier on this year. That information will be processed in the calculations that are carried out for the future. If you are utilising any other methodology such as the Glaser method, they don't do that. It's about averages and means as opposed to factual. So the Fraunhofer is about factual data as opposed to averages and means. So yes, the materials that are involved in the build-up will be taken into consideration. And indeed, if we can't get a proper analysis from it, then we'll sort of try and instigate something to have those products looked into in more depth.
Okay, and again, the good thing about the WUFI software is if you do have different projects in different geographical locations, which we do, of course, we have these types of projects all over the world where we supply, the software can be modified, right, Callum, to take that into consideration?
Yes, it can. So it can use any weather data from any weather station, really. As long as it's measured data, we can work with it.
Okay, great. Okay, a couple more here. In fact, I think this is the last one I have, which Adam, you've not been speaking for a little while as well. So do you have any U-value examples using your space therm products? We've spoken about a couple, but do you have any more examples?
Yes, there's a number of them really. Obviously, we've done lots of projects and we do mock-up examples for all of our literature and on our website that you can find. Let's take a 225 mil brick wall. which has no insulation on, that U value will be around 2.06. Then we'll take our space foam wall line of 13 mil, which will be 10 mil space foam blanket with a 3 mil magnesium board on it. Then the U value will be improved to 0.81. So that's a massive reduction for 13 mil. Again, about 61% heat loss within that build. So that's where the benefit comes into the product.
Good. Okay. Thank you very much. Great. So I believe I've got all the questions on email. If I've missed a couple, we will come back to you throughout the course of today. I think I've caught most on the live chat. Again, I'm sorry if I've missed any. We will go back through everything as they're coming in. It's been quite active. And we will go back through and make sure that we address any questions that have been asked. Thank you to Peter Cole, who said something nice about Roof Shield towards the beginning. I'm not quite sure what it was. But I do like to hear about people that like roof shields. And luckily on lockdown where I live, when I go for a walk, my husband and I go down the fields for a big walk, and there's a roof shield project. So it just brightens up every day, and he hears far too much about it. So thank you for that. And thank you to everyone for attending today's webinar. I feel like it's been a really beneficial kind of good 50 minutes, an hour afterwards with all the questions. It's great for us because we get the opportunity to understand the types of questions that specifiers in the marketplace has. And luckily we were able to answer most of them today, and we will have some action points to go and answer the ones that we couldn't off the hop today. So thank you for attending. I hope you find it educational and informative. We wouldn't be here if we didn't have the audience for it. So as I said earlier, we are committed to doing a weekly webinar every Friday during lockdown. And this is something that we may even consider extending afterwards based on the success of them. Next week's webinar is heat, air and moisture movement. Which is going to be really interesting. And I think I said earlier, from memory, we were going to aim it more towards the kind of commercial sector. So we'll have our commercial business development manager, Mark Lambourne. He'll be doing the presentation and answering questions afterwards, which will be fantastic. So he's got a wealth of experience in that sector. So 24th of April, a week today at 10 a.m. And then the following week will be live with impact and airborne sound solutions for floors. So please diary them if you can make it, come along. Personalised CPD certificates are available on the website, proctorgroup.com/webinar-certification. You will receive an email afterwards with a link to how to do that, and also a replay to this presentation, which you can circulate to anyone you like who may find it beneficial. So I think that's it. I just want to say a huge thank you to Callum, James and Adam. It's not easy answering questions on the spot when you can't make a face or look around and think, let me think about that one for a second. So it was really good having you on board and answering it. It was really appreciate it. And thanks again. As I say, please join us next week and enjoy the rest of your Friday and your weekend. Thanks, guys.
Thank you.
All right. Take care.
Bye.